Hello, and welcome to the Spec Shaman Podcast, the show that explores the world of building product manufacturers, architects, and engineers, sustainable design, and technology and trends. We engage in thought-provoking discussions with renowned experts, industry pioneers, and visionaries who are making a significant impact in the construction industry. Join us as we explore groundbreaking ideas, revolutionary concepts, and the latest advancements shaping the built environment. I hope you enjoyed this week's episode. Let's get started.
Welcome to the Spec Shaman Podcast. I'm your host, Megan Vipond, and today we're diving into something that impacts every building we design and specify, but often doesn't get the attention it deserves until something goes wrong: how walls manage moisture. We're joined today by Keith Lawley, President of Advanced Building Products, a leading U.S.-based manufacturer of entangled net technologies. With his expertise in building science and advanced wall systems, we'll be unpacking how innovation, testing, and code intent intersect, and what that means for design professionals navigating risk, durability, and long-term building health. Keith, thank you so much for being with us today.
Thank you for having me. I appreciate it. Okay.
It's always helpful to understand the path that brought someone into this niche of the industry. Could you share a bit of your background and how you came to be in this area of the industry?
Absolutely. I've been in the industry actually for 28 years. As you mentioned, I'm with Advanced Building Products. I'm the president and the partner here at the company. And this all started for me basically back in high school, when there was talk around the town of rebuilding our high school, and they wanted to get the buy-in from everyone in the community. So the architectural firm came in and they brought this model of this new school that they proposed to build. And as I was sitting there and looking at this model, I've always had kind of a marketing and a sales mind, but I really was intrigued by watching the design of this new school, looking at all the different components that they had and thinking to myself, wow, that was really cool how they designed this, just kind of thinking up these ideas. But more importantly, how is somebody going to actually build what this design was? And that kind of led me down the path of being really interested in construction, more from a conceptual side, from like a marketing, from a design standpoint. And when I went to college, I wasn't really sure which way I wanted to go, into architecture, into marketing, into design. And I learned my freshman year, after signing up for my first calculus class, that my marketing and sales mind was much stronger than my mathematical mind. So needless to say, I got more into the business side of construction as opposed to actually designing and doing the building myself.
Now, we hear the term used pretty frequently. So to kick things off, can you explain what a rainscreen is?
That's a great question, and one that is usually confusing. A rainscreen, the actual definition of a rainscreen, is that it is an assembly applied to the exterior wall, which consists of, at minimum, an outer layer, which is your cladding, an inner layer, which is your sheathing, and a cavity between them sufficient for the passive removal of liquid water and water vapor. Now, that's the technical definition from the Rainscreen Association of North America. What a rainscreen is not is a product. And a lot of times in our industry, people get confused with rainscreens as being a product, when in fact it's actually a wall assembly.
And could you explain the concept of a capillary break and why it is critical for drainage and ventilation?
Absolutely. A capillary break allows gravity to do its thing, basically. Instead of allowing the surface tension of moisture to span the airspace, there's a 5 millimeter building code that's out there right now that is basically allowing gravity to do its thing. And that's allowing moisture that gets through the sheathing, gets through the cladding, the ability to drain down and out of the wall system. Without a capillary break, any moisture that gets through the cladding is going to remain trapped within that wall system.
Now, why is the concept of managing moisture through design gaining a renewed attention across the construction industry?
Basically, innovations in claddings. Back in the day, you had basically three types of claddings. You had wood, you had vinyl, and on the commercial side, you had brick. Nowadays, there are a lot of different claddings that are available. So the problem with a lot of these claddings, although they're all very good, most of them, 81%, for example, are made from absorbative materials. So the buildings need to be built a little bit differently now than they did, let's say, 20 years ago. And that's where the capillary break comes in, because it has to be able to handle the moisture intrusion that will take place.
So, how do traditional cladding assemblies compare to today's ventilated or drained wall systems?
Traditional cladding assemblies, you're looking at what's called a face sealed assembly. And what that typically is you have your cladding that is up against your weather resistant barrier, which is up against your sheathing. Now, the problem with that type of cladding in today's environment is it doesn't allow any possible drainage or really any kind of ventilation. So today, with all of these absorptive claddings that we're talking about, you now have ventilated or drained wall systems. When it comes to a ventilated wall system, you have an opening at the bottom and an opening at the top, and it allows air to flow through the wall system in a convective fashion. With a drained wall system, that basically is a wall that allows moisture to drain out at the bottom, very similar to a cavity wall system in the commercial construction industry.
And what are some common misconceptions that exist around what a rain screen really is?
Well, the misconception, and unfortunately, a lot of us manufacturers are at fault for this. We sell products that are drainage and ventilation mats that are used in a rain screen wall assembly. But you'll see in a lot of our literature, it's considered a rain screen drainage mat. So a lot of people get a little confused thinking that a rain screen is an actual mat, when in actuality, as I mentioned earlier, it's an actual system. So that's kind of the misconception right there.
And are there certain project types where rain screen systems are mostly utilized, or maybe a sector of the industry where they're underutilized?
When you look at rain screen wall assemblies, it really depends on three things. The first being the location that the project's being built on. The next is what type of cladding are you using? And then third is what type of wall design do you want to use? Those are the three questions that you really have to ask yourself. And really, when it comes down to is any place in the United States, for example, that has over 20 inches of precipitation a year should really be designing with some kind of rain screen wall design. Because with 20 inches of rain, now just for example, that is basically the West Coast and basically east of Texas. You look at building codes, and building codes call out different zones and where you need to have this capillary break. So, for example, you have moist zone A, and then you have marine C. That's basically C is the West Coast, and A is what I just mentioned, Texas East. That's where you get the most significant amount of rain. So you need to have a capillary break there. But you got to take it one step further, and you have to look at zone B, which is your dry zone. That's pretty much in the Midwest, over like Arizona, Utah, those areas. It's also one of the highest areas for snowfall, typically averaging around 48 inches of snowfall a year. And as you know, when snow melts, it becomes liquid. You've got liquid up against your sheathing, up against your cladding, and you have moisture issues. So when you look at the United States and you intertwine those maps, you basically cover about 95% of the country that should be building with a capillary break due to this 20 inches of precipitation or more a year.
So now that we have that framework and distinction, let's get into how codes and standards are changing. How have the IRC and IBC evolved in recent cycles regarding requirements for drainage and capillary breaks?
In 2021, the IRC and the IBC basically put a figure to how large this capillary break needs to be. In the past, meaning 2015, 2018, they always spoke about designing a wall with a design drainage space, but it never indicated how wide that drainage space needs to be. Well, now it does. In the new codes, 21 and 24, it talks about 3/16 of an inch, or roughly just around 5 millimeters in thickness. Because of all the innovations that have happened with claddings, we now know there needs to be some kind of a drainage plane, as we talked about, and now we know it needs to be at least 3/16 of an inch. And there are many reasons as to why it's 3/16 of an inch.
Could you explain the building science reasoning behind the 3 millimeter minimum capillary break for drainage and the 4.5 millimeter gap needed for ventilation?
Absolutely. If you ever had a cup of water on your desk and you put your thumb and your pointer finger in that cup of water, saturate it, and then pull your hand out of the cup. Take your thumb and your pointer finger and slowly move it apart. And you're going to see that that moisture on your hand is going to bridge roughly 2 to 2.5 millimeters. So what that basically says is if you have a capillary break behind your cladding that is less than 3 millimeters, you can still have moisture bridging. You will not have the efficient drainage of 90% that it calls out for in the building codes. And when it comes to rainscreen wall designs, remember that a wall drains when it rains, but it ventilates 24 hours a day, 7 days a week. When I spoke about that rainscreen definition, I spoke about the removal of liquid water and water vapor. The emphasis is really on the water vapor and the ventilation. And to get proper ventilation, we're finding that 4.5 millimeters is the minimum requirement to get that convective airflow that you really need for proper drying within the wall system.
So it sounds like it's one of those details that can feel really small, but has a potentially big performance implication.
Unfortunately, when I give my AIA presentations, I have case studies and pictures that show just how big a problem a small gap can be. So less than 3 millimeters, I should say.
Absolutely. Now, what should design professionals understand about ASTM E2925 and its relevance to testing drainage and ventilation mats?
In the codes now, as you know, it calls out for the gap that we just spoke about. The big question is, how does a builder or an architect design this gap? You can't just leave an open space because you need to have a way to have connectors and to keep that space consistent. So what happened was we came up with ASTM E2925, and there's a bunch of criteria in there that basically calls out 3 different types of products that qualify to make this capillary break or this gap. Type A is an entangled net type material. It's a rolled product with a heat bonded filter fabric on one side of the entangled filaments. Type B is more of a dimple board type product, something similar that you see in below grade applications. And then type C is an engineered batten strip. Now, notice I said the word engineered, not wooden batten strip. And there are many reasons for that. Wooden batten strips have been proven to not only hold moisture because they're made from wood, but they're inconsistent because not all wooden batten strips are the exact same dimension, which causes trouble sometimes on job sites. The other thing with ASTM E2925 is there are a whole bunch of different tests that you have to meet, the product has to meet to actually qualify. So for example, you need to have a fire test on it. You need to have compression testing done. You need to have immersion moisture protection testing. Like, does this product absorb moisture in a wall? Is it going to break down in the wall over time? All those different things that are so important because when you put this product in your wall, it needs to last the life of the wall. And ASTM E2925 has all the different test criteria that you need to meet. It also says, again, the 3 different types you can have. So it's very important when architects and when even installers are using a product to create this capillary break, make sure the product you choose has been tested to ASTM E2925, because there are a lot of products out there that claim to be a rain screen, but they're not, and they do not have the testing to prove it.
So how can designers confirm that a wall assembly truly meets the intent, not just the letter of the code?
They basically need to make sure when they're meeting the letter of the code or the intent of the wall design that you're using either the drainage mat, the entangled net, the dimple product, or the engineered batten strip. You've got to make sure you do have that testing, because that testing is going to show that this product has been able to perform under the rigors of whatever environment that it's in.
What are some of the liability implications when a building is designed to outdated codes or if they omit current moisture management details?
Liability can now fall back on the actual designer. In the past, all liability always looked to the person that was installing the products on the job site, and that's not the case anymore. Homeowners insurance is a great example. Homeowners insurance covers $5,000 maximum for mold, rot, or moisture-related issues. If the current building codes are not being used and followed, All liability not only goes back to the architect, but it also gives a loophole for the homeowner's insurance to basically not pay for any of the damages.
How can documentation and specification language help protect design professionals from future claims related to water intrusion?
Basically, you just need to follow the codes. The new building codes, they're fairly specific as to what should be used and how. I'm very active in a group called RAINA, which is the Rainscreen Association in North America. And what we do with RAINA is we've come up with this installation guide. We've actually been working on it for the past year. And in this installation guide, it basically shows all different wall configurations and the recommendations on how to design these wall configurations with rainscreen technology. And using that and utilizing that third-party information is what's greatly going to help these architects and these installers on job sites.
Are there any specific details or admissions that you've noticed that tend to come up most often in moisture failure?
Yes, a lot of times we're seeing problems with the flashings and even the house wraps. So, for example, I've been on many job sites where house wrap wasn't even installed, or what's happened is the house wrap is not installed in a shingle style fashion, meaning the first course is rolled out, the second course is shingled over the first course, and so on and so forth, so water can shed down the wall. We're seeing it actually reversed so that the water actually is going to run down and past or behind the actual weather resistant barrier. A lot of times we see issues with flashing around windows and around corners.
Now, innovation often outpaces building code updates. How does that affect how walls are designed and constructed today?
That is the biggest hurdle that we have right now in the construction industry when it comes to being a manufacturer, because innovation is outpacing the ability to train the field. So what I mean by that is I'll be going to the International Builders Show next week, and you're going to see, or I'm going to see, all kinds of new innovations. The problem is we don't have enough salespeople out there to train every installer to install these new innovations properly. So that's why it is so important when manufacturers offer AIA presentations. They offer installation presentations. One of the great things that happened with COVID, believe it or not, is people are more acceptable of Zoom meetings and Zoom trainings. So instead of flying all over the country to try to train everybody, we can do mass trainings via Zoom. It's not as great as being face to face, we know that, but at least it gets the message out. It gets all of the technical data in front of people in a much quicker realm.
Let's talk now a little bit about the science of walls. We've heard there are 4 types of wall designs. Can you describe each and explain how they range kind of from least to most effective?
Sure. You've got your face sealed wall. You've got your drained wall. You've got your vented wall, and you have your ventilated wall. The face seal wall design is what you see in 98% of residential construction. And that's when you have your sheathing, your house wrap, and your cladding pressed right up against your weather-resistant barrier or house wrap. Your drained wall, that's a wall that has your sheathing, your weather-resistant barrier, sometimes 2 layers of weather-resistant barrier, and then your cladding pressed up against the weather-resistant barrier. One of the problems with this design is you have 2 layers, sometimes of like a grade D paper or of a house wrap, and they have a flashing that runs in between the layers. The layers are supposed to be waterproof, so the flashing that you have in your wall is in between a waterproof layer, so the moisture is really never going to get to that flashing. Sometimes people call that outer layer a sacrificial layer. They say that once it gets wet, it will crinkle up and it'll allow for some drainage channels. That doesn't happen because remember, you need to have at least 3 millimeters of a space to have a true drainage channel. These wraps, once they get wet, will not crinkle to 3 millimeters to allow proper drainage, especially in a stucco application. The third was that vented wall, and the vented wall is very similar to a cavity wall in commercial construction. And what that basically means is there is a gap in the wall. Moisture is going to get through that absorbative cladding, so the walls are designed with weather barriers, flashings, sometimes mortar deflections, drainage holes to get the moisture out. So again, vented walls are only at the bottom. We know it's going to drain. We know it's going to vent at the bottom, but we also know moisture is getting in, and there's nothing the wall design is going to do to prevent that. It's just going to handle it once it happens. The ventilated wall, which is a true rain screen wall design, now that's a different story. That's the optimal design because you have openings at the bottom and openings at the top of your wall. And what that allows is convective airflow within your wall system. When you look at a wall, you have positive and negative pressures. And the greater the difference between the positive and negative pressure, the more drawing power you're going to have getting moisture into that wall system. A rain screen wall assembly neutralizes the wall pressure differences. By neutralizing the wall pressure difference, you're not allowing excess moisture into that wall. You're controlling how much moisture gets in. And having that opening at the top allows that wall system to have an intake, which is at the bottom for drainage, and an exhaust, which is the ventilation at the top. And that convective airflow is drying the components within the wall system and keeping most of that moisture at bay. So basically, face-sealed wall assembly is your first option. A ventilated wall system is your last option, which is the optimal wall system. And the only thing you really need to do to go from what I'll consider the worst wall design to the best wall design is have that capillary break within the wall system and have those openings at the top of the wall to allow that convective airflow. A lot of times people think, oh my God, if I'm going to go from a face-sealed wall assembly to a rain screen wall assembly, how much is that going to increase my cost? The answer is roughly $1.50 a square foot. And remember, your homeowner's insurance will cover $5,000 when you have problems. It's very inexpensive homeowner's insurance, or for the actual homeowner itself, just to basically have that peace of mind of the drainage and the ventilation.
How could a poorly performing wall design be improved by simply introducing a ventilated or drained cavity?
If the wall already exists, let's say it's a face sealed wall assembly, for example, it's going to be extremely difficult to make that a ventilated wall system because you don't have the capillary break behind the cladding. One thing that we've done on commercial jobs that have a lot of water issues and efflorescence, let's say, for example, is we will open the top of the wall by using cell vents and putting a cell vent in the head joints. And basically what it does is it allows that convective airflow and it allows internal drying of that wall system.
What are some indicators that a design professional may be relying on an outdated wall assembly approach?
Well, first of all, and it's very frustrating, but with the codes the way they are right now, basically with the 24 code being live, we are seeing so many people still building and using the 2015 and the 2018 code. So we know that if they're following those codes, they're not building to the optimal wall design that is needed. Basically, they're building walls to claddings that were in existence 20 years ago, but that's not the cladding they're using today. A good example of this, and just kind of a quick little story, back when my son was learning how to ride a bicycle, he had his training wheels, he had on his helmet, his pads, and my wife stopped me short of wrapping him in bubble wrap because I didn't want him to get hurt. And that 4-year-old recently got his driver's license and came to me and said, Dad, I think I want to get my motorcycle license. And I said to him, what on earth makes you think you're qualified or have the skill level to drive a motorcycle? And he said, well, Dad, I've ridden a bike my whole life. It has 2 wheels, it has handlebars, it has handle brakes. The balancing's kind of the same. What's really the difference? And I'm thinking to myself, a motorcycle versus a bicycle, and he's asking me what the difference is. And it got me thinking about a lot of conversations that I have with builders. And a lot of builders tell me the same thing. They say, Keith, cladding's cladding. I've been installing cladding for 30 years. What's the difference? There's a tremendous difference. There are so many innovations in building materials and components to make up these claddings. It's not the same as the vinyl they used 30 years ago. And sometimes they just don't realize they don't know what they don't know.
How do climate, geography, and prevailing weather patterns influence which wall type performs best?
When you look at absorbative claddings and you talk about the different geographies, let's say, there are different ways that moisture gets into a wall. You've got kinetic energy, you have a capillary break, you have vapor drive, and pressure differences. So when it's a windy day and it's wind-driven rain, that's kinetic energy that's pushing up against your cladding. Now, your cladding is going to have hairline cracks in it because it's made from absorbative materials. And a lot of times I'll ask people, what's worse, a hole in your cladding the size of a golf ball or a bunch of hairline cracks? And surprisingly, a lot of people say to me, well, the hole, like the size of a golf ball, has got to be worse. And that's just the opposite, because hairline cracks are basically holes that are stretched out, if you think about it. And when you have that capillary break or that capillary action, and you have pressure differences that I spoke about earlier that are severe, it draws that moisture into the cladding. And that happens through vapor drive. And with vapor drive, you've got the warm trying to find the cold. And when that happens, that's when you have your dew point. That's when you have that moisture in the air turn into a liquid state. That's where you have your issues. So based on where you're building, you need to really make sure you have that capillary break to get that moisture to drain down and not remain trapped, or worse, go through your sheathing. Because believe it or not, not all house wraps are installed correctly. And sometimes they have tears, sometimes they have holes. And when you have moisture that has a direct path through a torn or a incorrectly installed weather barrier, that's when you're going to have your problems.
Can you discuss the role of an entangled net drainage mat in promoting airflow and moisture release within the wall system?
Absolutely. When you have an entangled net product, it's installed with the filter fabric facing out. And you heard me earlier say that it's a heat bonded filter fabric. That way it stays in place. Sometimes when you're putting up a drainage and ventilation mat, like an entangled net, it stays exposed to the elements for a prolonged period of time. You want to make sure that wind doesn't damage the product, doesn't damage the fabric. With a heat bonded filter fabric, that won't happen. With a glued on filter fabric, it could happen. So you want to be mindful of which one that you're using. The filter fabric actually allows the entangled net to stay and hold its shape and not be stretched on a job site, so that your 6 millimeter space does not become 4 millimeters. If you have any inconsistency with the thickness of the mat, you're going to find that out when you're putting your scratch coat, not your scratch coat, but your finish coat of stucco on your wall, for example. A lot of people think, well, an entangled net will give a wavy approach to the finished product on a wall. If you have an entangled net with a heat bonded filter fabric on it, that won't happen. Also, it acts as a mortar deflector. So if you're using a masonry cladding, for example, you're going to have a scratch coat that is going to be pressed up against the fabric. Any excess moisture is going to drain through the fabric and down through the entangled filaments that are keeping that airspace clear. That's going to give you that clear channel all the way down to the bottom. That's also what allows you to have a very small airspace. Because remember when I spoke about pressure differences within a wall, the negative and the positives, the quicker you can neutralize your air pressure, the better off you're going to be and the less moisture you're going to allow enter to the wall. So for example, if I had a 1-inch airspace, I have to let a lot of air into that wall system in order for it to neutralize. And as you know, moisture travels through air. So you're basically allowing moisture into your wall to get the neutralization that you need. When you shrink that airspace down to size, you're allowing less air in, less moisture, and you're allowing neutralization to happen much faster. That's extremely important. Also, you don't want to have an airspace that's over 1 inch wide, because an airspace of that size allows enough oxygen into that wall system to allow a flame to propagate up the wall, for example. If you have a fire on the first floor of a building, this capillary break is essentially creating a chimney. And you want to make sure that any fire is not going to spread up your wall quicker because of this capillary break. And when you stick to around 6 millimeters, there's not enough oxygen or air in that space to allow a flame to spread. Not to mention, an entangled net product has to be tested to ASTM E84 and have a Class A fire rating. That allows the installer, it allows the specifier to know that if there is a fire, this is not going to add to the problem.
Now, how does the physical structure of an entangled net create both drainage and ventilation pathways simultaneously?
When it comes to entangled net, you can manufacture them a number of ways. You can make them thin enough for certain applications that you can blow on them and they collapse, or you can make them robust enough that you can stand on them and they won't move. So it's very important that when you're specifying an entangled net, ask the manufacturer, what is the compression ratio? There are products that are tested on the market up to 2,500 pounds. Some are tested up to 25,000 pounds per square foot. 25,000 pounds is not necessary. When you're dealing with a sidewall application, you basically have to deal with the force of the fastener going through the cladding into the sheathing. And you just need to make sure that it is going to be good enough to have that open design so that it will not compress. Now, all entangled filaments are roughly made out of a 95% open design. So in other words, if you take a nail gun and you fasten an entangled net, where that nail penetrates the entangled net, it will compress the entangled net. It's supposed to. Now, if you take a 4x8 piece of plywood, 4 foot by 8 foot piece of plywood, and you put an entangled net down and you have 5 contractors stand on that plywood, the entangled net will not compress because it's not a point-driven compression you're concerned about. It's going over the entire surface area of that wall system.
In what ways do entangled net materials differ then functionally from drainable house wraps? And why is that distinction so important?
This is a great question, and one that is probably the most important question of this whole podcast. Drainable house wraps are just that, a drainable house wrap. They're a very good house wrap, but they are not a rain screen. They do not perform a rain screen function. And there's a lot of confusion in the industry right now that a drainable house wrap is an inexpensive rain screen, and it's not. And here's why. A drainable house wrap typically has corrugations or dimples to it that are about 1 millimeter in thickness. Now, remember earlier when I said how the surface tension of moisture can span 2.5 millimeters. When you have a 1 millimeter, but the moisture can span 2.5, you have a potential problem where the moisture can literally get held up on some of those dimples or some of those protrusions in the drainable house wrap. Now remember, to be a rain screen, you need to drain and ventilate. To get true ventilation, you need a minimum of 4.5 millimeters of space. A drainable house wrap, to my knowledge, goes 1 millimeter. I think I've seen one that goes 1.5 millimeters. I've never seen a drainable house wrap, to my knowledge, that is 4.5 millimeters or more in thickness, which means there's absolutely no ventilation capabilities of a drainable house wrap. You'll hear people in the industry talk about a rain screen and a true rain screen. There is no such thing. There is a rain screen wall assembly, and there are products that are used to create the capillary break to make this rain screen wall assembly. Those can be found in ASTM E2925, type A, which is the entangled mesh, B, which is that dimple board I spoke about, or C, which is the actual engineered furring strip. Nowhere in ASTM E2925 does it call out a drainable house wrap. Now, nothing against drainable house wraps. They are good house wraps, but they are what they are. They're a house wrap. They're not an engineered drainage and ventilation mat.
So how do these systems help equalize pressure and prevent capillary action within the cladding cavity?
In order to really be able to equalize pressure, you need to have that opening at the bottom and opening at the top. Think of a rain screen wall system like a car engine. In order for a car engine to perform correctly, you need to have an intake and an exhaust. If you have a car that doesn't have an exhaust system, your car's not going to run very well. The same thing can be said for a rain screen wall assembly. You need the intake, you need the exhaust, you need to have that convective airflow. Allowing air into that wall system is what is going to equalize the pressure. And I really shouldn't use the word equalize because that's really not realistic. It's neutralize the air pressure, because when you allow wind and everything coming up against your wall, if you're going to have a 35-mile-an-hour wind 24 hours a day hitting your cladding, you get a chance of pressure equalization. But that's never going to happen. It's going to come, it's going to go. It's never going to actually equalize. You can compartmentalize your wall system to get as close to equalization as possible, but neutralization is really the goal that you have. Keep that positive and negative as close to neutral as possible, and that's going to basically allow the convective airflow. It's not going to allow that moisture, excess moisture, to get in past the cladding.
Performance is one thing, but durability over time is where these decisions really show their value. So let's get into material selection. How can design professionals balance cladding material choice with appropriate cavity design?
First, you need to figure out where is the project being built. If you're going to build on the coast, that's a lot different than if you're building in the middle of the country. So basically, if you're building on the coast, for example, you know you're going to have kinetic energy. You know you're going to have moisture-related issues. So it's extremely important to have that capillary break that we spoke about. Also, look at the building codes. Right now, there are 37 states that have adopted the building code with rainscreen technology.
What are the most common failure mechanisms you've seen in wall systems that lack proper drainage and ventilation?
The most common failure mechanisms really are the design of the weather-resistant barrier. When it comes to pressure neutralization, none of this is going to be possible if the weather-resistant barrier is not installed correctly. And what I mean by that is you can't have gaps in your weather-resistant barrier. Your sheathing has to be consistently covered. I've been on many job sites where they'll do a great job on the north side of the building, and then on the south side, one whole row of the weather-resistant barrier is missing or it's not tacked correctly, so you have basically exposed sheathing. You need to have that weather barrier intact and the flashings intact, because as that air is being entered into the wall system, if it has opportunities to get past the weather-resistant barrier, you're not going to get the neutralization that you really need for a rain screen wall assembly. So really, in order for a rain screen wall assembly to perform at its optimal level, it all starts with the weather-resistant barrier being installed correctly.
What lessons can be learned from projects where a lack of ventilation caused premature cladding or substrate failure?
Well, the lessons that can be learned is always check the soffit area. That's where you're going to typically have your exhaust, or you're going to have your ventilation, your top ventilation. A lot of times I'll have people that will install our products and they'll call me and say, Keith, come over to the job site, take a look at the product. And I'll go over there and our product is installed on the wall, but I noticed that the installer went right up to the soffit and then put their cladding right up underneath the soffit. And there's no space for ventilation at the top. So what they basically have now is a vented wall, not a ventilated wall. And that's where you're going to start to see, a lot of the projects that are going to have premature cladding failures and whatnot, because the moisture is in there, but it's not getting out the way it should. Take it a step further. I've been on job sites where not only did they not put the ventilation gap at the top of the wall, but at the bottom, they went with a bead of sealant and they sealed off the bottom to make a nice clean edge. And I say to the builder, you don't have a ventilated rain screen wall here. You don't even have a vented wall here. And then the installer will look at me and say, well, what are you talking about? What do we have? I said, you have a problematic wall here, because what you essentially did was create a basket for any moisture that gets past your cladding to remain trapped in that wall. There's no drainage at the bottom and there's no ventilation at the top. And the crazy thing about moisture issues is a lot of people think it's an old home issue. Most of the restoration projects that I've been on are on homes that are less than 3 to 5 years old. So this is not a old home issue, it's a new home issue. A lot of times contractors will ask me, Keith, why do I care about drainage mats and rain screen wall systems? I've been building for 35 years. I've never had a problem, never had to do this. Well, they're right, because I've been on some of those projects that are 25 years old and the homeowner wants to change out their cladding. So we rip off the cladding, the weather-resistant barrier is damaged, so we tear that off and we see the sheathing. And you can see right through the sheathing because it has gaps in it. Well, there are no moisture issues because air has been blowing through that wall system for 30 years. It's been drying the wall system for 30 years. The problem is your heating costs and your air conditioning costs have been blowing through those walls for 30 years as well. And now that we're being so energy conscious nowadays and everything's being wrapped really, really tight, now more than ever, you need to have that ventilation and you need to build for it.
You mentioned heating and air conditioning costs. So, do ventilated wall assemblies contribute to occupant comfort then beyond just moisture control?
100%. One of the big things in construction nowadays is indoor air quality and obtaining good indoor air quality. And a great example is a school was built 5 years ago, not too far from where I am right now. And the kids were coming home complaining to their parents about a weird smell in the classrooms. And it went on for a while, and some of the teachers had parent-teacher conferences, and they could smell it too. And they knew, well, that's a musty smell. So we brought over some masons and we opened up the walls, and we found a ton of mold and rot within the wall systems. If you have moisture issues in your wall system, it's going to affect the indoor air quality. And as you know, with energy efficiency being what it is now, we're putting more outboard insulation in our projects, which is great. But the problem with that is, you need to have the ventilation to allow the products and to allow the wall system to be healthy and to keep your R values up, keep your heating costs down. That's the whole point of all this. Wrap your buildings tight so you can save on your heating costs. The problem is, if you're not careful, you're going to jeopardize your indoor air quality if you don't design your walls with these rainscreen wall assemblies.
And have you noticed that owners are becoming more receptive to investing in these better performing systems when long-term benefits are communicated?
The problem that we have right now as manufacturers is finding the homeowner. It's real easy to find a distributor. It's real easy to find an architect. It's not always so easy to find the next future home builder or the homeowner that's getting their house built. When you do get a chance to speak to them and you talk to them about the added cost, but the benefits of that cost, it's a no-brainer, and they want it all the time. The problem is, a lot of times, as I mentioned, with the educational purpose of this, not all installers are familiar enough with rainscreen technology to build walls to these rainscreen principles. So they don't try to sell the homeowner on this technology. They try to just do it the way they've done it for the past, 15 to 25 years. So that's kind of the struggle that we have right now. And that's why it's important to spend a lot of time with homeowners associations, and just getting out there at lumber yards and talking to people, because it makes a world of difference when you're building with a rainscreen wall assembly. I've got jobs that I've built on the coast 5, 7, even 10 years ago, and the cladding looks as good today as it did the day it was finished. And if the cladding looks as good today as it did the day it was completed, that means the interior wall system is as healthy today as it was back then, which means the indoor air quality is as good today as it was back then. And that's really what it's all about.
So what are some best practices for coordinating air barriers, rain screen components to perform together as one system?
What I would recommend is install these products separately. And what I mean by that is there are some great house wraps on the market nowadays. Some of them are self-adhesive. Like I said, there are some drainable house wraps that are out there that are very good. There are very good drainage and ventilation mats out there, as I've mentioned, with the entangled net products, for example. The problem is innovation sometimes needs to stop. Innovation means new. It doesn't always mean better. And what I mean by that is I get asked so many times, Keith, can you take your entangled net and bond it to a house wrap so we can do it as a all-in-one system? Yes, we can do that. And here's why I recommend you don't. You have an entangled net with a 6 mil product on it. A house wrap or a weather barrier is only as effective as it is installed, and you have to have your seams taped properly. You can't properly tape your seams when you have an entangled net or a dimple board or something else on top of the weather barrier. So you really want to install these products separately to create the system. Don't try to find an all-in-one system, because the attention's in the details, and the details will not be done correctly if you do it this way.
Now, when it comes to sustainability, what are the benefits that come from designing walls that can dry out naturally?
Well, the benefits of walls that dry out naturally is, A, it prolongs the life of your cladding. It prolongs the life of all the components within your wall system. Keep in mind, if moisture can't drain, the surfactants that are going to come through your claddings are going to stay trapped on your weather-resistant barrier, which in time will degrade your weather-resistant barrier. I've been on jobs before with like galvanized reinforcing products, and they're rusted out because moisture has stayed trapped within the wall system and rusts out the actual structural elements of the wall system. So you need to have the ability for that to dry naturally, and not just that, but if your wall is drying naturally, you're not going to have any kind of moisture issues in your sheathing, which will eventually get through your sheathing into your insulation. Once moisture gets into your insulation, you now have compromised the R value of your wall, the insulated principles of your wall system. And once you have that, you now have studs that are rotting, and you now have indoor air quality issues. So having that capillary break to allow natural ventilation and drying is key. Because remember what I said earlier, it only drains when it rains, but it ventilates and dries 24 hours a day, 7 days a week.
How do these strategies extend the life of the building envelope and reduce maintenance costs over time?
Most rainscreen wall assemblies that use an entangled net, a dimple board, or a engineered furring strip, most manufacturers offer warranties. So right there's peace of mind to the homeowner of the warranty, which is that extra insurance policy that I spoke about earlier. So that's really, really big. From a maintenance standpoint, having that capillary break again is not going to allow moisture buildup, which is going to greatly reduce any kind of maintenance. A lot of times people see cladding and they see like the paint is blistering or peeling, and they think, oh, all right, maybe it's time to repaint my house. That's not usually the problem. If you have blistering of paint, usually you have moisture in your wall system that is driving back through your cladding, causing that paint to blister and to peel the way it is. So again, that's why that ventilation is so crucial. And having that ventilation with the openings at the bottom and the top, that's really, really important.
So let's ground all of this in real world experiences and maybe take a look ahead a little bit. But could you share some insights from a real world project where moisture management, or maybe the lack thereof, had measurable impacts?
Absolutely. When I give my AIA presentations, I show a case study, and it's a beautiful home on the coast in Cape Cod, Massachusetts. It's a home that is less than 5 years old, and it was made with cedar shake, cedar siding. It's a beautiful home. And the home had severe moisture issues. And what happened was they used 2 layers of grade D paper as the moisture protection. They did not follow ASTM E2925. They did not follow they did follow the local building codes at the time because the capillary break was not in the code at that time. But on the coast, you have that kinetic energy. You have the absorptive cladding. You have the differences in temperature. So you have like the perfect storm forming, basically. And what happened was, not only did the moisture get past the cladding, it got into the insulation, it got into the studs, it got into the sill plate of the house. And one thing that I didn't mention earlier, but weather-resistant barriers on a 2,500 square foot home have roughly 6,000 nail penetrations. Now, that's 6,000 opportunities for moisture to get past the cladding, past the weather-resistant barrier, into the sheathing where it's going to wreak havoc. And that's exactly what happened here. And I was on the job site that day talking to the builder, and I asked the builder, I said, can you give me an itemization of what it's going to cost to fix this? So he did, and I showed it in my presentation. And the bill for restoration was just under $100,000. And I spoke to the homeowner, and she said to me, this is a real inconvenience, but it's okay. We've got great homeowners insurance. We'll be fine. And I tell people during my presentation, that's when I should have gotten in my truck and left. But I stayed for the rest of the day and talked and walked around the job site. And the insurance company called later that afternoon while I was there. And their insurance covered $5,000 maximum. And that's $5,000 that I spoke about earlier in this podcast. And I thought, wow, they must have a horrible homeowners insurance policy. Well, I happen to know some people that own insurance companies. So I called them and I asked, and they said, no, Keith, that's the national average. $5,000 is the protection for mold, rot, and moisture-related issues. Needless to say, the homeowner went from relatively calm to relatively irate pretty quick. And that's what can happen in a short amount of time. Again, it's not an old home issue, it's more a new home issue. And that double layer of grade D paper, it wasn't installed correctly around the windows, and that's where the problem started, and it spread from there. I've got video in my presentation of the builder with a crowbar literally taking the studs of the house apart like paper mache. It was unbelievable just how weak the structure got. And there are many other examples that I could tell you about. There was one out on the West Coast. It was a high rise, and it was about $170 a square foot to fix. And I'm talking a high rise of, I think it was 9 stories, and they had mold and rot throughout most of it. And everyone had to move out while it was being done. So those are two that really jump out at me as eye-opening experiences.
Looking ahead, how do you expect adoption of rainscreen and entangled net technologies to shape future codes and best practices for resilient, healthy buildings?
Really, the proof is in the pudding. And what I mean by that is buildings that are being built and have been built over the years with rainscreen technology, they look as good today as they did when they were built. And the architectural community is taking note of that. The codes community is taking note of that. That's why not only is this in the 2021 IBC and IRC, it's in the 2024. And I've gotten word it's going to be in the 27 code as well. And if people are going to always build a few code cycles behind, this technology is going to be around for a long time. What we need to do, and I know it's easier said than done, it would be nice if builders could only build one code cycle behind, because so many people are trying to build to the 2018 and 15 codes because that's what they're comfortable with. It's what they're used to. But you got to look at building codes as installation instructions. When my kids were little, at Christmas time, we'd get them toys and I'd have to put them together Christmas morning, and I'd open up the box and there was a white piece of paper in there that I'd always kind of throw to the side, and I'd build the structure. And at the end of the build, it was always nice that the manufacturer gave me a whole bunch of extra pieces, because that white piece of paper that I kind of cast aside, well, those are like building codes. If I would read the instructions, I would have built it correctly. They didn't give me extra pieces. I just missed a lot of steps. And building codes are the same way. Builders today that are out there building, know the code, know what you're doing, know what you're building to. Don't be afraid of the codes. I mean, they're huge code books. I get it, but they're your instruction manual to allow you to build correctly, to build efficiently. And the claddings that look like the ones from 20 years ago aren't made like the ones from 20 years ago. So just embrace the codes. Don't be afraid of them. And if you are, there are a lot of manufacturers out there that would love to talk to you, love to help you, and love to train you on how to use these products.
And what is one final thought or some words of wisdom you would like to leave our audience with?
Allow moisture to drain, not remain. As cheesy as that sounds, moisture is the cause of 90% of wall failures in construction today. 81% of all claddings used today are made from absorptive materials. The only two that really aren't are vinyl and metal. And we find rainscreen technology is being used behind a lot of metal claddings because metal heats up in the sun and you have air-conditioned space on the inside. And remember how we spoke about vapor drive? You're going to get condensation buildup when you have heat and cold and when they find that dew point in that meeting place. Allow ventilation and make sure you have a convective airflow. Always think of a wall system like a car engine. It's going to work the best if you have an intake and an exhaust. So remember, allow moisture to drain, not remain.
Amazing, Keith. Thank you so much for sharing your insight and expertise with us today.
Well, thank you for having me. I appreciate it.
Now, moisture management may not be the most visible design decision, but as we've discussed today, it is clearly one of the most significant. We appreciate you joining us on the Spec Shaman podcast as we continue exploring the details that make great architecture possible.
Thank you for listening to the Spec Shaman podcast. If you enjoyed today's episode, please subscribe to our show and leave us a review. A huge thank you to our guests who made this show possible. Thanks all for this episode, folks. See you next time.